Okay, so we're going to stay with the topic of AI for our next presentation, because our next presenter is concerned that some of the hype around AIs risks obscuring the fact that AI is already creating real and significant value for the organizations that know where to look for it and how to unlock it. And here to tell us how that's done, please welcome to the stage Vice President, Global Emerging Practices, AI and Deep Learning, Atif Kureishy.
Okay, well, good morning, everyone, and welcome to day 3 here at Universe. And so, as we heard from Dr. Aisha, I want to carry forward a lot of the themes that you just heard, but what we're going to do is we're going to focus the next 30 minutes on really unpacking some of the details and the real-world implications of applying AI. So we'll actually look at 2 different scenarios, we'll play some videos, and we'll peek behind the scenes and understand what's actually going on. Now, what's important here is that as we go through this, I want to be focused on dissolving the hype and really understanding how do we do this at scale to drive answers. And at the end of this, my objective is to have convinced you all that you play a significant role in advancing AI within your own enterprises. So let's get started. Now, over the last decade, AI has experienced a renaissance, and particularly in the last few years, driven by the research and applied research communities. There's a distinct focus on deep learning. And poised to disrupt several industries, deep learning is already providing value and uncovering answers to some of the most difficult challenges in a wide range of industries. Now, these breakthroughs in AI really center on 2 essential parts. And when these 2 parts are combined, they allow us to make increasingly accurate predictions equating to better answers. Now, the first part, more data, is where we're seeking a broader perspective of including new dimensions and new features of data that describe all aspects of our business. And I'll expand on this in a moment. The second part, now that we have this expanded view of the data, we can apply more learning algorithms. And specifically, these learning algorithms have been really driven and fueled by innovation of the open source community. And now we're seeing that the cost barriers are being removed, so now the applications are starting to open up, where different traditional machine learning approaches are doing much better and providing significant lift over statistical-based methods that have been there before. And when applied correctly, that significant lift is allowing us to extract hidden signals and patterns across this more data. Now, with all of that optimism and breakthroughs, the reality, though, in the enterprise today is that we're falling short of delivering those better answers. And so we have to ask ourselves some key questions, because there are several considerations. How do we design an architecture that provides a consistent computing environment across the edge, in the cloud, and within our own data centers that allow us to experiment with real-time and batch-oriented scenarios? How do we get access to those GPUs to accelerate the training of our models and apply inference at scale? How do we blend traditional machine learning approaches combined with these deep neural networks to automate the labeling and extraction of features? With these hundreds of models, how do we manage the overall life cycle and consider model risk management principles like model safety, model stability, and as Stephen talked about yesterday, model bias? Yes, these challenges are daunting, but they can all be overcome and addressed. And I'm here to tell you that the essence of what enables better answers is a robust data foundation that allows these predictions to reliably occur at scale. And we're at a key point where a fundamental paradigm shift is happening, and we all need to be aware of this. Traditionally, and up until now, we've been programming with software using data. Our future will be defined by programming with data using software. Let me say that again. Up until this point, we've been programming with software using data, and our future will be defined by programming with data using software. So in the first instance, and what we all traditionally know, is that when programming with software using data, we, the developers and engineers, provide that understanding and implement that in software code, and that logic is defined and supplemented with data. And typical applications that we are all familiar with work in that way. But in the future, we're going to specify an outcome where the understanding of that outcome is buried in data that we have access to. And so programming will take the shape of learning and optimizing from the data guided by using software. So let's look at this data a little bit closer. So over the last 40 years, we've captured transactions from operational systems and now can provide a highly curated data set that yields extreme value that powers our businesses today. Now, within the last 20 years, we've been focused on understanding the high-velocity data that's generated from the interactions from mobile devices, web browsers, and social media. Interactions are human-generated and define human decisions. Clicking on an ad, watching a Netflix video, texting, tweeting, browsing, all examples of interactions. Now, the next 20 years will be shaped by our ability to extract value from previously intractable data sets, derived from those IoT device sensors that provide us rich media like images, audio, speech, and video. Now, these observations are machine-generated, and they're proliferating in an exponential rate. These observations are machine-generated, but they also observe human behaviors or other machines. And it's not just the domain of Silicon Valley tech giants, for instance, identifying a face so you can tag that face in Facebook. This observational data is in your enterprise today. High-resolution line scan cameras capturing different stages of the manufacturing fabrication process. Closed caption TV recording traffic patterns in smart cities. Audio recordings from rotating machinery in planes and trains. Retail store surveillance provided for loss prevention. Camera, LiDAR, and radar from vehicles providing driver assistance and autonomous capabilities. Drone footage to improve safety and yield in the energy and agricultural sector. All of these are observational data that's in your enterprise. So let's pivot now. As I told you, we're going to look at the real-world implications of applying these learning algorithms to this expanded view of data. And what we're focused on in the two scenarios that we're going to describe is driving the outcomes that we're all very familiar with. How do we improve the customer satisfaction and improve the customer experience, but at the same time reducing the cost to serve? So do more with less. I think all of us have been challenged with that. Now, the scenarios that we're going to look at are specifically in a retail context, but these concepts apply across every industry. So I ask for your creativity as you have a look and listen in. So as we're watching these videos, I'll describe what's happening, and we'll start to understand some of the subtleties of applying these AI-based approaches. And then we'll take a moment to unpack what's going on and actually look at the processing pipeline behind the scenes. Now, what's fundamentally different about what we're going to have a look at is that we're using state-of-the-art AI techniques based on industry best practices. And fundamentally, we're trying to understand what our customers are doing across space and time in a physical brick-and-mortar location. We'll then take that understanding, build upon it, in order to provide better answers. Okay, so in our first scenario, we're looking at a 45-degree camera within the appliance department of a retail store. Now, the legend that you see at the bottom, you see we have two subjects, a customer and an associate. And then we have the circles of different colors representing the types of activity that those subjects are performing. So as we play this video, you'll see the little circles will start to increment a counter, and that describes the duration that that subject is performing that activity. Okay? And we're going to loop this and describe some of what's going to be happening. So the first thing I want you guys to focus on is the couple in the left-hand aisle. As they traverse down the aisle, right now they're in a walking activity, and you'll see they'll start to engage with that appliance and transition into an engagement activity. Also, you'll see their path form along the floor plan. Now, if we look on the right-hand side, in the right aisle, we'll see a customer-associate pair. And specifically there, you see another engagement activity and counters associated. But what you'll notice is that each one of these subjects, we're giving an ID, a temporary session ID. And if we detect a face and localize that face, we actually blur it out. And now the last thing to notice is some additional complexity of this camera. It's actually a PTZ camera, which is a pan tilt zoom camera. And if you look closely, you'll see the panning that's actually occurring, which we have to compensate for that movement when we determine the pathing and the activity detection. So hopefully this gives you a really intimate understanding of some of the capabilities that we can start to understand and derive from the computer vision techniques that we're applying here. And again, as I promised, we'll peek behind the scenes at what's really going on. And I do want to mention, by the way, there's no on-screen magic here. This is actually video that's been pushed through our pipeline. Now, the second example and scenario is focused on a retail branch location. Now here, the camera, you'll notice, is actually in a lower location of the store. And of course, this introduces some amount of complexity because you actually have more occlusions in the image space, meaning that there are more barriers in terms of a line of sight. And so we have to really think about the concept of re-identification. And so what's important to a branch manager? Okay, what branch managers are struggling with is that they have a really good understanding of what occurs when a particular transaction takes place. You go up to a teller, you go up to a banker, you enroll, you make a deposit, so on and so forth. That's a well-understood interaction, if you will. But what they don't know is what happens before that transaction and after that transaction on a consistent basis. Yes, they can put personnel in the branch and observe and do a time and motion study and what have you, but we're talking consistently and pervasively what is occurring before and after the transaction. And so what we're really trying to understand and protect against is walkouts. And we've all been there. We've walked into a financial center, we've gotten into the line and we've started to queue, or we're signed in waiting for a banker and sitting on the couch, and we realize that our time is too valuable and we walk out the door. So here in this video, you can see we have two subjects, a teller and a banker, three subjects, teller, banker, and customer. So I'll play the video, and what we see is behind the counter, we have two tellers, we have three customers queued up in the line, and then we have a banker and teller pair on the couch. So customer number 4 in this instance is now engaging with the tellers, and the tellers are being obfuscated because of the occlusion of the counter. And as the customer passes in front of them, it's important that we re-identify them properly. Now you can see the customer walks away, the transaction is completed, and he is very excited, obviously, had a great interaction, and he's really satisfied. So as a branch manager, I want to be able to understand what was the nature of that transaction, why did that sentiment occur, and how do I replicate that customer experience? And then what you can see is some of the diffusement of that emotion to others that are in the queue. All right, so from these two scenarios, let's look at what's really going on, okay, and dive into the specific details. But before I do that, I want to talk about privacy, ethics, and compliance. So clearly a theme over the course of these 3 days from all the speakers highlighting the importance of privacy and ethics. And so it's important very much in the context of the capabilities that we're talking about here. GDPR and other emerging regulations are being derived, and it's important that we take those concepts and apply them in a first-class way to ensure that we balance from the onset how we leverage these techniques and ensure that the right controls are in place to prevent unintended abuse and exposure to fines and other sort of risk management principles. So with that in mind, let's step through and see how we leverage this processing pipeline to rapidly extract features from our observational data. Now, the first step is we need to baseline our understanding of the existing store performance. And very straightforward concepts that you all are familiar with is sales, inventory, payroll, financial and operational reporting, all of the standard things of trying to understand how we're doing today. The nuance here is as we try to apply computer vision, we need to also understand and calibrate our approach based on the technical capabilities of the retail environment. And we have to be considerate of if we're trying to do this across hundreds or even thousands of retail locations. And most importantly, we need to understand the network and camera infrastructure from a technical perspective. Second, we want to effectively detect the subjects in our retail environment using a multi-camera, multi-object fusion-based approach. And here we apply different CNN architectures, convolutional neural network architectures, that are trained for subject detection. Now third, once we can detect the subjects, we have to be able to do that in every frame that we sample, assigning a temporary session ID and then using re-identification to form that path. So now we can associate a session for each subject during the duration of the time that they're in the store. Next is to then apply different machine learning classifiers to understand what type of subject is it. Is it a banker? Is it a teller? Is it a manager? Is it an associate? The things that are important for our understanding. We can then apply physics-based models and deep learning models that help us understand what activity is being performed. And this could be done by understanding the velocity of our subjects, of how if they're standing still or if they're in motion. If they're demonstrating a certain pose, we use pose detection approaches. If they're close to other associates or if they're close to a product, we use distance considerations and proximity. This allows us to understand what activity is being performed. Walking, queuing, dwelling, product engagement, customer engagement are the ones that we saw in our video. And now, probably most importantly, with the aggregate of all of these techniques, we can now run experiments in our store using familiar A/B test approaches, champion-challenger test approaches, where now we can reconsider product placement. We can reconsider our product mix and assortment, run different promotions, change our planogram. And since we've baselined our store performance, we can start to understand and measure the impacts of those changes. Now, at the end of this processing pipeline, what do we get? And from the table you see up here, we get vision metadata. And so essentially, we are deriving structure from our unstructured observational camera data. And if you look at these columns, you see that we have a subject, what camera that subject was captured in, a timestamp, what was the activity, and then what was the XY location based on the collaboration, or the calibration, I should say, into the physical floor space. Now, this time series data is captured every 1/7 of a second, and your question would be, why? And that's because our camera resolution is at 7 frames per second. The sampling rate of our cameras are at 7 frames per second. Now, these two rows in particular highlight the transition of a customer who's walking and then moving into an engagement activity, as illustrated in our appliance example. All right, so intriguing and fascinating, but simply tracking and classifying the motion of subjects in a retail location in absence of a broader context is actually very limiting, and will leave us with more questions than answers. But if we connect this vision metadata with other dimensions of understanding, we get a much richer context of how these customer behaviors are influencing our store's performance. Now, it's important to note that we don't ever directly link to a customer. Okay, we want to make sure that we implement those controls aligned to privacy, policy, and ethics. Now, with this richer context, we can start to ask ourselves much more interesting questions, such as how does customer engagement and queuing times impact our store sales? How does a marketing promotion influence the conversion rates in the store? And if you're thinking to yourself, we've been able to do this before on the web channel, mobile channels, you're absolutely right. And so what we're talking about is applying a lot of those concepts around web analytics and conversion and click-throughs, and now being able to do them in a physical location. So we can provide our retail operations leader with more understanding of the relationship between wait times and engagement. More specifically, how does that relationship influence conversion or walkouts? We can give them more distinct answers that tell them move a product to a new location based on an understanding of a customer engagement, footfall traffic, and related product sales. Another answer to store performance could be to increase staffing in a specific department based on a promotional campaign that is being run, given that the high wait times are traditionally in that department. So you now know this as pervasive data intelligence, bringing together analytics at scale across your transactional, interaction, and observational data. Here, pervasive is about reducing complexity and increasing ubiquity. We don't want to just keep this vision metadata with our retail ops group or R&D teams. Instead, we want to make sure that it's integrated and connected so that facilities management, HR, sales and marketing all have the ability to discover, connect, and interact with this data. Anyone now with a basic understanding of business intelligence can begin to benefit from the breakthroughs in AI. By applying pervasive data intelligence in this retail context, we can now improve our customer satisfaction and reduce the cost to serve. New opportunities start to emerge now that we have this capability accessible to us. We can now optimize our floor plan based on the path traversal of our highest value customers. We can reduce walkouts by intervening and engaging customers earlier or preempting and understanding those early warning indicators. We can improve operational efficiency and uncover those best practices that cause our customers to dance. Many retailers and branches are rolling out next-gen concepts without fully understanding the implications of those concepts. But now we have the understanding to say and measure exactly what the customer response is based on those next-gen adjustments. So what about cost to serve? The opportunities from a reduction of cost are now being able to optimize the staff scheduling and deployment as we understand the dwelling and queuing times of our customers in specific departments or in specific locations. We can improve the staff productivity and training through quantitative measures. We can build better staff forecasting models through customer behaviors. And we can provide lower cost self-service offerings on our digital and mobile web channels by understanding in-store activities and in-store behaviors. So I hope I've convinced you not only that we can derive better answers from AI, but that you all have a key part of enabling that AI-first future. Yes, there's a lot of hype around AI, and the technology is sure to evolve. But remember, AI is already creating value if you know where and how to apply it. Seek and unlock that observational data in your enterprises. But keep in mind that the real value of those new rich media data sets only emerge when they're integrated and put into a larger context, enabling new creative use cases that drive transformational business outcomes. So I hope you've enjoyed our time together, and if you wanted to learn more, I wanted to offer our free ebook, Achieving Real Business Outcomes from Artificial Intelligence. The QR code is actually right there. You can also go to teradata.com/AI. In the book, we talk about several other use cases and considerations around building these AI types of capabilities. Thank you.
Atif, thank you so much. I hope you enjoyed that as much as we did.
Yeah.
In fact, there's a little bit of me that hopes you're so stoked that in the minute you're going to dance off stage just like that guy danced out of the back.
I don't think you guys want me to do that.
Okay, but before you go anyway, a question for you. I mean, this was a fascinating presentation. You talked about the importance of combining the observational and the contextual. But I guess Aisha touched on this earlier as well, right? A lot of organizations are kind of intimidated about taking the first step. So what's your recommendation for this audience? What should that first step on this journey be?
Yeah, so I think what you mentioned is absolutely right in the sense of data is a key consideration. But what's essential, and what you've heard from Dr. Aisha as well, is that you have to be able to frame this to leaders in the business and enable a new creative or very compelling opportunity to pursue. And this could be, a wide range of things. For instance, if we can now improve the overall P&L and reduce costs in our stores, that's really compelling. And so these capabilities can be better understood once you put it in that context. But then very quickly, you also have to syndicate the understanding towards your legal and counsel teams. You have to share that with your retail operations leaders, with your IT teams. Because remember, if these capabilities existed today, it would be easy, right? But we have to be able to cut across those organizational silos and bring folks together.
Super. Atif, thank you so much.
Yeah.
Ladies and gentlemen, please put your hands together one last time for Atif Kureishy. Ladies and gentlemen, we're at the rest and refreshment break. The expo is closed today, so coffee is served on level 0, so the level you'll be at when you climb the stairs to leave the auditorium, and it's on the left-hand side of the atrium as you come into the building. We'll see you back here for 10:50, please. Thank you.
Saw the pills on your table for your unrequited love. I would be nothing without you holding me up. Now I'm strong enough for both of us, both of us, both of us, both of us.